What's up, folks? Welcome to Math Walkthroughs with Mr. Weeb. Today we are solving problems involving decimals and whole numbers in our Lesson 5 Your Turn questions. And today you might notice that there's the UPS problem-solving sheet right beside this. We are solving these problems using this method. So the first thing that we need to do on each one is to understand the problem by reading the problem, bracketing the question, talking about what do I know and circling the important numbers and underlining what those numbers mean. Then we're going to choose a strategy and then we're going to use that strategy by solving. So that's the UPS part. The last part that is very, very important is the checking part. We need to reread the problem, answer, like, did we actually answer the question, and find out, is the answer that we gave reasonable? So let's try using it for number 1, which says, a bag of potatoes is 4.5 times the mass of a 2.4 kilogram bag of snack mix. How heavy is the bag of potatoes? Solve the problem and show your thinking. So the first thing I need to do is put brackets around the actual question. I want to know how heavy is the bag of potatoes. Then I'm circling important numbers. There's an important number. The bag of potatoes is the thing that is 4.5 times the mass. So it's not the bag of potatoes that is 4.5 kilograms. It's times the mass. So, and that is the bag of potatoes right here. So that's kind of the bag of potatoes, but it's in relation to something else. Let's circle the 2.4 kilogram, and that is referring to the bag of snack mix. Okay? And it gives me basically a number sentence in words. So I don't need to plan too much. I have a number sentence here that I can just write down. All I need to do is 4.5 times 2.4. And then I just carry out that multiplication. 4 times 5 is 20. 4 times 4 is 16, plus 2 is 18. Then I put a 0 here, and I carry on, do the same thing with the 2. 2 times 5, 2 times 4. So first, 2 times 5 is 10. Carry the 1 up here. 2 times 4 is 8, plus 1 is 9. Now I add this all together. I've got 0, 8, 10. And how many decimals do I have? Or how many numbers behind the decimals do I have? I've got 2. So I'm going to have 2 decimals. Is that what I expect to do, to see? Right? This is the final step, is I am checking. I've gone through the understand, I've planned, I've solved. Now I'm checking, does 10.8 make sense? And I can do that by using estimation. If I would say that 4 times 2 would be 8, well, that would get me close to the answer. And I would say that if I have 0.4 and 0.5 more than that, then I would expect that my answer would be more than 8. And 10 is indeed more than 8, but not a crazy amount, too much. So then the last step is to actually put my answer in a actual sentence. Bag of potatoes would be 10.8 kilograms. And I like to have the answer in a rectangle because that shows you this is the important stuff. All right, let's go to the next one. About how many pencils could be placed end to end to make a line that is 5 meters long if each pencil is 0.15 meters long? Solve the problem and show your thinking. Okay, understanding. What is the actual question being asked? How many pencils could be placed end to end to make a line that is about 5 meters long? That's the actual question. Then let's circle some important numbers. 5 meters is an important number, and that is referring to a line that is 5 meters long. Another important number would be 0.15, and that refers to the length of each pencil. Okay, so how many pencils could be placed end to end? Another way of saying that is, how many of those pencils could fit onto a line that is 5 meters long? And that sounds like a division question to me. So I would write this question as, what would 5 divided by 0.15 be? So let's write it out like this. 0.15 goes into 5 how many times? Well, in order to do this, I need to take this decimal and move it over 2 decimal places. And same thing with this invisible decimal. I need to move it over 2 decimal places as well. There's a 0 there and a 0 there. So the new question becomes 15 fits into 500 how many times? Okay, 15 fits into 50 3 times, because 3 groups of 15 is 45. Right? If you think about the minutes, 15 minutes, half an hour, 45 minutes. So 3 times 15 is 45. Now I subtract. I've got 5 here. I've got 0 here. 15 fits into 50 3 times. 3 times 15 is 45. Do the subtraction. We've got 5 left here. The 0 can come down. And it looks like we will have 33.3 repeating, because this pattern is going to go on forever. Now, does 33.3 repeating pencils make sense? The question is about how many pencils could be placed. So since we're not going to have a remainder of a pencil, we're just going to have about 33 pencils. And we just need to write that in a sentence. As always, I should double check. Have I actually answered the question? The question was, how many pencils could be placed end to end to make a line that is 5 meters long? And about 33 pencils should fit. That should mean that 33 times 0.15, and I can double check this, 33 times 0.15 should be approximately 5 meters. Okay, let's do the math. 5 times 3, 15. 3 times 5, 15, and one more is 16. I put a 0 and I multiply the ones. 1 times 3 is 3, 1 times 3 is 3. Now add those together. We've got 5, we've got 9, and we've got 4. And how many decimals do we have in the question? We have 2 numerals to the right of the decimal here, and nothing to the right of the decimals here. So that means we have 2 decimal places here. 4.95 is very close to 5 meters, so that makes sense. Let's go on to the next question. A pitcher has 6.2 liters of water in it. Raji pours water from the pitcher into 7 glasses. Each glass has 0.275 liters of water in it. How much water is left in the pitcher? Solve the problem and show your thinking. So to do this, let's first bracket around what the actual question is. The actual question is, how much water is left in the pitcher? So we'll put brackets around that. Then let's circle some important sounding information. 6.2 liters, that refers to the pitcher of water. The pitcher of water. There you go. Raji pours water from the pitcher into 7 glasses. So the 7 refers to the number of glasses. Each glass has 2.275 liters of water. So this is an important number, and that refers to each glass of water. How much water is left in the pitcher? Okay. Next, after understanding the question, now we have to plan. What method are we going to use? What strategy should we use to try and figure this out? Well, I might draw a picture, okay? Pictures can help a lot. Here's my pitcher of water. My picture of a pitcher of water. Here's a little handle, okay? And then there's a little bit of water in it. We've got 6.2 liters in that pitcher. He pours from the pitcher into 7 glasses. 1, 2, 3, 4, 5, 6, 7. Each glass has 0.275. In each of them. Okay, so what we could do is we could just multiply 0.275 7 times, right? Because this happens every time in each of these glasses. So let's do the math up here. 0.275 times 7. 7 times 5, 35. 7 times 7 is 49. And we've got 52 when we add the 3. Then we've got 2 times 7, which is 14. Add the 5, we've got 19. 0 times 7 is 0 plus the 1. There we go. And how many decimals, how many numerals are after the decimal in this question? And it looks like 3. So it's 1.925. So it looks like there are 1.925 liters of water out here. So that means 1.925 liters has been taken away from the 6.2 liters that we had in the beginning. So let's take that 6.2 liters and take away 1.925 liters. Well, in order to do that, remember, when we're subtracting, we do have to stack those decimals one on top of the other. We'll give some zeros over here. We'll borrow from the 2. That becomes a 1. This will become a 9. This will become a 10. 10 take away 5 is 5. 9 take away 2 is 7. We can't take 9 from a 1, so we're going to borrow from the 6. This will be 11. Take away 9 is 2. There's the decimal. 5 take away 1 is 4. And we should have 4.275 liters left in the pitcher. And all we need to do is put it in a sentence and then check to see if our answer makes sense. Now, have we actually answered the question? Let's see. The question was how much water is left in the pitcher. Okay, we started with 6.2 and then we took away 0.25 or 275. We took away another 0.275 and another 0.275. I noticed that 0.275 is close to 0.25. So if we counted quarters, just to make sure that this number makes sense, we would have 1 quarter, 2 quarters, 3 quarters, 1 liter. And then we would have 1.25 liters, 1.5 liters, 1.75 liters. Okay, so this number here isn't 1.75 liters, but it makes sense that it would be more than 1.75 liters because this is more than 0.25. It's just that 0.25 is a very friendly landmark decimal that we can work with. So when we did that, we checked it out. And then if we were to subtract 2 liters, this is almost 2 liters, right? If we were to subtract 2 liters from 6.2 liters, we would expect to get around 4.2 liters, which is what we've got. So this answer totally makes sense, and we can rest assured that we got it right and move on to the next one. And there's nothing wrong with checking it on a calculator as well when you're done. The last question says, Leslie's brother weighs 16.7 kilograms. Leslie weighs 12.4 kilograms. Leslie's dad weighs 67.6 kilograms. How much heavier is Leslie's dad than the 2 children? Let's start by using our trusty UPS method. Understanding first. First, we want to see what the actual question is and put that in brackets. So the actual question is, how much heavier is Leslie's dad than the 2 children together? Next, we're going to circle some important numbers. So we've got 16.7 kilograms. That is how much Leslie's brother weighs. So we'll underline that. Then we've got 12.4 kilograms. That's how much Leslie's dad weighs. Oh, sorry, that's how much Leslie weighs. And then Leslie's dad weighs 67.6 kilograms. That's how much Leslie's dad weighs. Okay, now that we understand the question, we need to make a plan. So what strategy will we use? I'm going to draw a picture, I think. And so let's start it out with the solving part. Here's Leslie's dad. Okay, he's a big boy. It's just a very simple question. Simple, not a stick figure, that's for sure. And he is 67.6 kilograms. And we want to know how much heavier is Leslie's dad than the 2 children together. So we need to find the difference. And when we're finding the difference between 2 weights, that's a subtraction question. So we need to subtract the 2 kids together. So here's one kid. And here's the other kid. Okay, we've got one kid is 16.7 kilograms and the other kid is 12.4 kilograms. And we need to add these guys together. And we're going to take all of these guys and subtract them. So we're starting with this much weight and we're taking away this much weight. Now, when I have a multiple choice question like this, I don't necessarily need to get an exact answer. Although for this time I will. I could though estimate first just to make sure that it's going to make sense. My estimation would be this is real close to 70, right? And then these guys, I could just add 17 and 12, which would be, let's see, 29, right? So that's close enough to 30. Okay, so let's say it's 70 take away 30. I should get an answer that's close to 40. That's my estimation. Well, now let's see what we actually get. According to BEDMAS, we would need to add the children first. So let's do that. We'll go 16.7 plus 12.4. We're adding those together. 7 plus 4 is 11. We've got 9 here, and we've got 2 here. So 29.1 kilograms for the kids. Then we have to take that amount away from the dad. So we go 67.6, take away 29.1, and we'll get, let's see, we need to borrow from the 6. 17 take away 9 is 8, and we end up with 38.5 kilograms. And it looks like this is going to be our answer, which was very close to our original estimate. That's it for today. Thanks for watching.